How's everyone doing? How many of you have been to FIPS in the last month? No? Y'all get free access as students. If you didn't know that, FIPS is just an amazing place right across the bridge, sort of towards Carnegie Mellon. And I think in the winter, it's an especially nice time. It's just like indoor rainforest, essentially, you can walk around. Nice seeing everyone. Max and I went to FIPS over the weekend, just had a nice little lovely time. How's everyone doing? Nice to hear it. It's always nice seeing all of you. We have a medium-sized one today. This is not one of the big ideas, not one of the small ones. We're going to sort of work using some of the similar tools, but with some new ideas. So we're going to look at numerical variables by category, which I think will feel pretty familiar in a lot of ways. We've talked about basically all of the tools we're going to use today, but we're just going to use them in a slightly different way. And I think we're going to pull a lot of ideas together in a way that will feel productive. So you all are working on your projects, and some of the skills we're about to work through, I think, are just incredibly useful when working with real data. So I'm going to show you an example of sort of a messy problem, and then we're going to try to resolve it using some techniques to think about categorical data by, numerical data by category. This is sort of in between what we talked about last time, which was bivariate data. So you'll remember we talked about relationships between multiple variables. So this was, we had numerical variable on the x-axis and a numerical variable on the y-axis. And we realized we can't just summarize data and use summary statistics. This really obscures underlying relationships. So we talked through this, I think, amazing example, what's called Anscombe's quartet, which is just a visual way of understanding one of the core problems with summary statistics. So we walked through the scatter plot. We talked through how to read this, how to think about ratios. We talked about linear scales on the vertical and horizontal, and then we also introduced this idea of using a log transformation. So we had a log on the horizontal axis to give us more visible detail between small values, and while preserving the sort of ordering of large values. So the log scale gives us both of those things. We also talked about log-log scales. So this is when both x and y are logged. And then we talked about a third axis. So we have three numerical variables. We can, use size and color to encode this third variable. But this is really not one of the great applications, I think, of data. You can do this, and we do, but it's not a great visualization. It doesn't communicate a whole lot more than just a simple scatter plot. You can see the sizes, but it's not really a systematic display. Okay, and then we had color, which maybe was a little bit better, but not dramatically. So that's what we did last time. We're turning our attention now from numerical by numerical to what happens when one of the second variables is categorical. So how do we work with that kind of data? How do we answer questions using that data? This will lead us into our last topic in part 2, which is numerical by categorical. So I think part 2.3 is really the big one of part 2, which is how do we explore relationships that vary by category? So we're going to think through some visualization techniques. All three of these summarization approaches are going to be very useful for us when we hit part 3 and part 4. And then one of them will be useful in part 5. So when we start developing our models of inference. All right, how's everyone doing? Y'all here? Nice to see you. So we have two homeworks due this week. One is 2.2 and then one is 2.3. Those will be both posted pretty shortly. All right. Isn't she just adorable? We had family come in this weekend, and she just had the most amazing time. She didn't take any naps all day because she was just so excited to see everyone. Okay, so what we're going to try to do today, I have this interesting data set. How many of you have been to Starbucks recently? Okay, no one? There's better coffee in Oakland. So some of you go to Starbucks, some of you don't. So for a long time, I guess there's a movement to stop using the Starbucks app. But if you use the app, Starbucks will send you little pings, so like promotional deals on your phone. So you get like a notification on your phone. Y'all know what I'm talking about? Be like, if you buy coffee within the next 2 days, here's a buy one, get one free. So Starbucks does this kind of thing. They'll send out these little promotional offers. And if you're interested in behavioral economics, we often think about like how these kinds of little subtle things can impact behavior. So what we're going to do today is use this data set to try to examine which promotional offer moves behavior the most. So I have a bunch of interesting data, and we're going to go through it. So these are just some of the offers. So here's like a BOGO is like buy one, get one free. For a long time, I didn't know what BOGO meant until I was like 25 probably. And then we have 2 off 10. So this is a promotional offer. If you spend $10, you'll get $2 off. And then the same for some of these others. So this is like $5 off of 20, and we have a bunch of others. We're going to look at 5, and we'll focus on 2 at the end. Okay, so my main question is something like this, like which one of these moves behavior the most? And you can think of like, if you're receiving one of these pings on your phone, which one is going to be the most compelling? Like, are you going to want to buy 2 things instead of 1 if you get a BOGO? Is $5 off of a $20 order going to be compelling to you? I don't think I've ever ordered $20 worth of anything on that app. So is this useful? Is this one maybe better? I also don't think I've ever spent $10 at Starbucks. So thinking through, the incentives that are going on. I'm going to show you some of the specifics. So this is the data. We're going to load this in a second. But this is what it looks like. We have a bunch of rows. We have a bunch of events. So these are different kinds of events. We'll explore this in a second. We have this column called revenue, which is just sort of business speak for like how much did the person spend. So this is how much money is coming in from the order. And then this is the offer that was used. So we're only looking at offers where an offer ID was used. So one of the promos, and we can track which offer was actually used. Okay, so my main question, we're going to look at all of the different offers, but the big question is this one. Is BOGO 5 or BOGO 10 going to see the highest average spend? Like, which one of these is going to move customers the most? Maybe just as like a warm-up question, this is a question for you. Like I sat down, as I was working through this problem, I sat down and thought about what would feel most intuitive to me, like which one of these would move customer behavior the most. Turn to your neighbor, tell them something fun you did this weekend, and then which one of these do you think would move behavior the most? Is that fun or stressful? Okay.
I think it's like if you get one, you get it.
It's if you spend $10, you get one $10 item off for free.
Okay.
I mean, like when I go to GMC and it's like that type of thing, like buy one, you get like one half off. I'll always like buy the more expensive one so I can get more money off it. But I don't know if that's like not
So would Burger 10 just be the same as 10 off 10? Like, I'm confused.
Sort of.
It's like you buy something and get the same thing.
Yeah. So if you spend it'd sort of be like it'd be more similar to if you spent $20, you would get $10 off. But it's not quite the same because like the comparable item you would get for free may not be worth $10. So it's like it's not exactly the same as like $10 off $20, but it'd sort of be I think more similar to that. Yeah, fair enough. So what do you all think? You're economists. You're thinking about behavior and responses to incentives. Any ideas here? Just going in without knowing what's in the data, what might we expect? Yeah, Mairead. Okay. Okay, so it's maybe easier to use BOGO 5. Like you don't have to spend $10 to get one for free. Yeah. Any conflicting opinions here? Yeah.
I feel like it's because like if you're getting a deal, like a lot of people think like, oh, if I get something bigger, it's more justified because I'm getting more off.
Okay.
So I feel like kind of in one's head, it's like, oh, if I'm only getting 5 off or something, I might as well get it.
Yeah. So something like an excuse almost. It's like to justify the big expense, I need a big reward. Yeah. Okay. Any other ideas here? Let's find out. So we can actually go to the data and check. So we're going to do that over the next half an hour or so. So what first we're going to do, and we're just going to jump right into the exercise. We're going to look at revenue by offer type. In the exercise, we're actually going to try to answer this question. We're going to visualize the data, whether BOGO 5 or BOGO 10 has the higher average spending. So there's some code in the slides, but we're just going to start by loading the data set and then running that in the notebook. Yeah.
Is the data set in the? I can't find the data set.
So it should be.
The directory in the notebook isn't working. It just goes to the data. I think usually.
Oh yeah. Didn't this happen last class? Is this 2 classes in a row the notebook isn't working?
I thought you usually had the data set like you download it or something.
That's the way it should be. Yep. So hold on just a second. I was walking into class today. I was like, I'm not going to have any of these issues today. But I was thinking, if I do have one of these issues, I've never figured out, do I get lecture points or do I lose lecture points?
You get lecture points.
I get lecture points? Okay.
You get double this week. You get 20 this week.
So it's like every sequential class. Yeah, so I'm going to fix the file path. Sorry about this again. Say hello to someone next to you. Or just sit in silence. That's up to you. Or gaze at the cuteness of this little child.
Did you get up to this weekend? I'm the new club on campus and we had a rugby game on Sundays. I didn't play this week. I didn't have a. I was random. And I was
So did you grow up playing?
no. It's a very because they have it's like what was the club called? The new it's the cafe. But there are two men's houses like kind of associated with the club, and it's like the one house versus the road is like the name of it. They've been doing it for like 17 years, and the one house hasn't won. They've won like 4 times. They finally won it this year, the first time in 7 years. Making laundry Sunday night.
I work at like I'm a kitchen staff.
Yeah. I'm making exam on Thursday. Leicester. Lecture, so everything through the exam is from the semester. So today's lecture is for the next week. It's our lecture time is actually just like so I go. I was like, dude, I'm not going and study and stuff. And I didn't get it. Like so many things.
I just had a class in Kathy, and it got cut short because fire alarm, fire cat.
Was there a fire?
I don't know because they have it at what, like 12:30. I don't know. Let's just like go hang out for minutes until this class when we come back for 5 minutes before we go back inside. Yes, and so just missed the fire.
All right, so it should be on the, it'll update on the course page, but in the meantime, I put it on Canvas if you want to access it there. So next week, when I mess up the link in the slides, that's 30 lecture points?
I think it'd be fun.
40? Is it double every time?
Yeah, double.
Okay. Okay, so this is running on my end. So before that unfortunate interruption, what I was asking you to do is we have this question, so we have this little data set, and we're curious about sort of the distribution of revenue by category. We could also think about the average revenue by category, and so it's our job in the exercise as we're getting started here to just visualize the revenue by offer type. Anyone able to access the notebook?
Yep.
Nice. That's what I love. Okay, so we're in the notebook. I've loaded the thing. I'm going to go up here to save a copy and drive. So we'll take a second here. I want you to think, before I give you the answers, I want you to think through what you would do to summarize revenue by offer type. I've given you some hints, but I want you to think it through. Like, what are we trying to do? What's the visualization intended to do? And then once you create a visualization, what are you seeing? How does it help you answer the question at hand, which is which offer type is most useful, or like moves behavior the most? How many of you have a nice little figure? How many of you have a figure? Okay, so some of you have nice figures, some of you just have figures. Someone want to tell me what you did? I know some of you are still working, which is great. Yeah.
Created a box plot, so for ID on the X, rather than the Y instead.
Okay, so just copying my notes. Yeah, nice. So we have sns.boxplot. Do you like the notes, or would you wish they were not there? Yeah. So maybe 10 lecture points for giving you solutions. Okay, enough of this. So we have boxplot. We're going to use our data set. So we have to go up here, find our data set, data. And then we have X. We want this to be, so if I'm thinking about how I want this figure to go, I've given you some notes here, but as you're constructing these, think through what you're trying to do. So I want maybe offer ID on the horizontal axis, so multiple boxes ordered horizontally. You could do this vertically if you wish. Sometimes I prefer that. But my horizontal is just going to be offer ID. And then my y-axis is going to be revenue. So I'm looking up here at the different columns and thinking about which one I want to display vertically and horizontally. And so if I plot this, I have a lot of outliers. I'm going to use wis is equal to 0 to 100, just so I can see the whole thing. Okay. So I've told you what my observation is, but if you were to look at this figure and try to answer the question, what's the core problem? Yeah, Evan?
All of the improvements, like everything is down at 0.
Like, these box plots are clustered around 0. So I can't tell visually, like the point of a visualization is that we can see the differences, right? Like we can see what's going on. But with this figure, I can't actually see what's going on. Any questions about the visualization itself, getting this set up? Yeah.
What is informative?
Say that again?
Informative? What is that variable?
Informative. Oh, this last, this one here.
Offer.
Yeah, good question. So what's that doing there? The rest of them are pretty clear, I would say, right? So like BOGO 5, buy one, get one free if you spend more than $5. BOGO 10 is the same idea. Then we have the like 3 off 10 or 2 off 10, so $2 off if you buy $10. 3 off 7, that's a really good deal. 5 off of 20. We'll have to investigate what informative means. What else are we seeing? Yeah.
Very high outliers.
So the outliers are just really extreme. Someone is spending $1,000 at Starbucks. I've never spent anything close to that. I don't think I've even spent like more than $7. So this is not what we want, right? Our main question is, like, is the average different between groups? Something along those lines. And this doesn't give us really any indication of that. Any ideas for what we should do? Well, you could look in the slides, or you could look in the exercise. I've given you some notes here for code as we go through. But essentially the main idea, when we try to summarize numerical variables by group, much like we did with time series, when we were plotting seasonality, where we give separate box plots for different seasons, or we used box plots, I think in a couple of contexts, we used box plots to just give us like multiple years, so distributions across time. Here we're using numerical variables in a similar way, but showing distributions by category. So fundamentally the same visualization tool, just a different application. And this allows us, at least in theory, to make comparison questions across distributions. But this figure, like we just showed, is not very informative, so to speak. So any ideas what we should do? Really, everything's compressed at 0. Any ideas about how we fix this problem? How do we make this figure more informative for us? We have a nice tool. Yeah, Kim. Okay, so that's exactly what we're going to do. Kim, right? So Kim is saying, let's take the log of revenues and plot that. So that's the next thing I'll have you do. So we're going to use a log base 2 to construct revenue. So essentially, every time we increase log base 2, we're doubling the size. So every 1 increase in the log base 2 is a doubling of revenue. So for example, and we're also going to use 1 plus, just so we make sure we don't hit zeros. So this is log base 2 of $7 is going to be 3. Log base 2 of $15 is going to be 4. So we've doubled the input. And then log base 2 of 31 is going to be 5. So this is like 2 times 2 times 2 times 2 times 2 is 32. Any questions about logs? A little later in this semester, we're going to spend more time interpreting these things. For now, just think of this as a way of rescaling the data so we can see both large and small values. Kim?
Does the base matter?
It changes, the different bases change the interpretation of what the log is doing. So here we say, because it's log base 2, it's every time you increase by 1 log unit, you're doubling. You could have log base 3, which would tell us that every increase in the log unit, you're tripling. We often use log base 10, which is an order of magnitude for every log base, which is actually the scaling of decibels are, I believe that's log base 10. The Richter scale is also in logs. I think hurricanes are also measured in a similar way. Okay, so we're going to spend more time thinking about logs. But the first thing we want to do is create a box plot with the log transform variable. So I've given maybe a little bit of a hint here. But I want you to play around a little bit. There's code in the slides if you get stuck. But what we're going to do is construct a log base 2, and I want you to add 1 inside the parentheses when you construct your log base 2. So I'm going to push you a little bit. You've done logs, but I want you to play around a little bit with the code to create this log base 2. So we'll take maybe 2 minutes here, and then we're going to do it together in the slides. Almost, bless you. So some of you will be feeling like this is no problem. I expect that's not many folks in this room. If you are, that's great. If you're feeling a little confused about how to proceed or like how to think through the code you're writing, this is the expected state. So I expect you to not know like immediately how to write this down. you're going to encounter that kind of feeling often in your life, also often in this class. Learning how to sit comfortably with not knowing exactly what to do, that's an amazing skill. One of the most important skills you can develop. And then thinking about how you can proceed. And then turning and looking at this cute child whenever you get stuck. Okay, how many of you were able to construct a log base 2 variable? Okay, maybe 5 folks proudly. Someone want to? How many of you are like in the ballpark of something? A few. All right. So, someone want to walk me through what you did if you got a log base 2? Yeah. Remind me of your name. I'm sorry. Matt.
So I just first created just log underscore revenue as the variable.
Okay.
And I said equals and then just np.log2.
Okay.
And then you said to add a 1 in the parentheses, so then I created the parentheses for 1 plus, and then just to access the variable revenue in here, I just did data and then bracket revenue.
Okay. So Matt gave us a really nice outline here. The first thing we do is we construct a new variable. So all we're doing with this line, or this part of the line, is just telling Python to create a new variable that we're calling log2 underscore revenue. Then we're going to set it equal to something. And then the thing we're going to set it equal to is some log transformation of something, right? So this is the numbers package, and then we have log. In the past, we've worked with log with no number after it, which I believe that's the natural log. But then we want to give it something. We're going to add 1 in front of it, just so we don't, if we put in a 0, Python doesn't know what to do with log of 0. That's undefined. So we're just going to make sure everything is 1 or greater. So I'm just going to say 1 plus, and then we're going to give it the revenue column. So this is just data and then revenue. If we run this, we get our new logged transformed variable. Okay, any questions here? So your job is to visualize this variable using one of our main approaches. So we'll take about a minute here. Construct a nice visualization, turn to someone next to you and tell them which group looks like it has the highest average revenue per transaction.
Yeah, I don't know. The strict one looks mine looks different than mine. Yeah. But like reading the slides, it just looks different. It makes no sense. Like literally this code does not give you this much.
All right, someone help me out here. What are we looking at? So I'm just going to add the box plot and the strip plot, and then we'll run off to the races. So we have our box plot. I'm going to add whiskers, and then we'll just add the strip plot. So SNS.strip plot, and run these. Okay, so what is this telling us? Someone want to try to interpret this figure for me? Does this look funny? Why does this look funny? Like, what are some of the weird things about it? Pete?
The lower end of the box plots for every single one moves at 0, not even like a lower whisker, just the bottom of the plot itself is at 0.
Yeah, so we've never seen this before, right? The box doesn't have a median that we can see, and it doesn't have a lower whisker that we can see. Anyone know what's going on with this? Like, how could there be no lower whisker?
The median is at 0.
If the median is at 0 and the minimum is at 0, then there's no difference between the median and the minimum. So the lower half of the box is just squished up together. And that's exactly what we're seeing here. So this tells us the lower end of the box plot, the minimum, is identical or equal to the median. How is this possible? This is weird. How is this possible? How is it possible that the minimum is 0 and the median is 0, but we still get stuff like this? Yeah.
It'd be like there's just super people that in the box and people that see the offer but don't buy anything.
So it could be that so many people see the offer, but for whatever reason, there's no transaction associated with that offer. And what this is telling us is that that's the most common case. The median is that. So there are a couple ways of seeing this in the data. The first is that the box plot was kind of squished down to 0 like we saw it. The second, and this is part of the power of a strip plot, is we can actually see data points grouped all at 0, right? Let's just look at this figure for a second. And I have a better one in the slides. Let's just look at this for a second. This is the same data shown in the same way. I think it might be a little prettier in the slides, but fundamentally it's the same figure. We have, so for 2 off of 10, we have the distribution of log revenue. And we see that the median is at 0. So the whole box is squished up against 0. We can also see from the strip plot that there are so many zeros. And you can see that by this little bit here. Just all the data points are sitting directly on top of each other at 0. So this tells us something, that many of the offers are not being used. There's no really transaction associated with them. You're not buying anything with these offers. This also, in some ways, like clears up the question about this informative column, which is like, it's just, we can interpret this as being a bunch of offers that are sent out, but don't have an associated code with them. It's just, we're running, we have this new item, like pumpkin spice lattes are now available at Starbucks. There's no discount associated with it. It's just an information ping. Okay, any questions here? Yeah, Zach.
How did you get the colors on the?
Yeah, so let's see. If you wanted to add color, you could add hue. So you could do hue by offer ID. I think that would add separate colors. And the data points on the strip plot are really opaque. So one thing you could do is change this to alpha, make it really small. there's lots of data here, so it's going to look pretty funny. I think I might have taken a sample, so you could do sample just 1,000 of them, something along those lines. So you can play around with different ways of visualizing the data, but fundamentally, like kind of whatever approach you take, you're going to be able to see this fundamental problem. Any questions here? Does that work for you, Zach? So this is not something summary statistics can tell us, right? It would be very challenging to see these nuanced problems in our data without doing the visualization. Okay, so what are we going to do instead? So we know we have these zeros. Do you all think we should keep them, or should we try something different? Mairead is saying take them out. Anyone want to make the argument for leaving them in? Evan is answering for the entire class. No one wishes to keep them in. The argument for keeping them in is if we wanted to know the average effectiveness of an offer, like if I send a ping to your phone, I want to know how much I would expect in return. And to do that, I have to consider whether you actually take up the offer or not. But another question, right, is when people use the offers, how do those compare? And that's the question we're going to answer with the rest of class. So what do you all think we might do to think about this? Like how should we handle this zero problem? Y'all leaving me on red? Evan?
Could we like only take data points greater than 0?
So we could filter by 0. So we could just look at revenue and then select only the ones that are greater than 0. Yeah. So that would be one approach. Can I show you this data again? So I guess I don't have it in the slides, but if you look at so one approach would be to filter for revenue that's greater than 0. Did you all notice this column, event? No? I think one thing we can do in these kinds of situations is try to understand everything that's in our data set. And in this case, that's actually going to give us a clue about what we should do. So let me just, the first thing we're going to do is create a summary table. We did this in part 1.1. So you'll remember, like, we were going through and counting up entries by category in part 1.1 with coffee shops. So we're just going to create a summary table counting unique values. So we can use this thing called value count. We've used it before, so I'm not going to talk too much about it. But essentially, this just goes through and counts up all of the separate entries in the column event, and then we just count up what's going on in each. So how many times each is showing up. And what we're seeing here is we have offer, which is one kind of event that shows up 76,000 times. We have transaction, which shows up 30,000 times, and then offer completed, which shows up 3,000 times. So what we're seeing is we have a couple of different rows that are showing up, 3 different kinds of entries. And my hypothesis is that this, looking at transactions versus just the offer being sent, may tell us what's happening with the zeros. All right. So what do you all think we should do? Like, is this, when you see this, does this give you an idea about what to do? What are some of the ideas? Like, what should we be doing after realizing that there are multiple kinds of events? Yeah, Pete.
I would assume that offer just means that you're going to have an
Okay.
So you could just use the data from transaction, and that would eliminate needing to do any of the zeros.
Okay, so maybe we just focus on the transactions and not the offers, because it could be that the offers are just being sent out, but there's no actual, transaction that's happening for them. Yeah, so I think this is a great hypothesis. What might we do to confirm that? How might we test whether there's revenue coming in only through transactions? Evan?
I have a question.
Yeah.
What is the difference between the transaction and offer complete? Is like transactions through the app, regardless of an offer like being pinged about?
Yeah. Yep. So this is a good question. So we have 3 categories here. We have offer, transaction, and then offer completed. And so we're sort of curious whether, is there any revenue coming in through offer completed?
Yeah, so we would just want to look at offer complete.
So maybe we just look at offer completed. Or maybe as Pete is saying, we just look at transaction. How do we figure out which one is the right approach? Yeah.
Well, if we're comparing the different offers and their effectiveness,
Yeah.
then we're going to only look for transactions that are through the offers, that by the offers.
Yeah. Right. So we really only want to look at the transactions that are bringing in some money. What I might do in this case is to try to resolve which category we should be looking at. What if we just plot the distribution of revenue by event type, and we just look at which ones are actually bringing in some money? Does that sound appropriate? Let's do that. So what I'm going to do is just, you can do it this way. I'm not sure why I wrote it like this in the slides. What we want to do is just create a bar chart. So we could do like a count plot like we did in part 1. So we could do sns.countPlot. And so I'm going to give it the data set data. And what I want is on the horizontal axis, I mean, you could do this on the vertical axis too. I just want to go through and count how many times each one of these values is showing up. Maybe we do this up here. So count plot, and then I'm just going to say x is equal to event. And that gives us each of the counts. But what we want is to go through and add up all of the revenue by group. So we want each one of these offers, and then show the distribution of revenue by group. So to do this, I would just plot something similar, except I would show the distribution of revenue. So revenue on the vertical axis, and event on the horizontal axis. So let's do sns.boxplot. We have data, and then the horizontal axis, I want it to be event. The vertical axis, in this case, I want to show the distribution of revenue. So I'm going to use y is equal to revenue. And then we'll set the whiskers equal to the whole range. And when I run this helps me answer the question we're after. We can make this even better if we used our nice log too. And I think this helps us answer the question, where are the revenue transactions coming from? Yeah.
Not the offers.
Not the offers. Yep. So offers are not bringing in anything. These exactly, sort of as we hypothesized, are the rows that we just see the offer going out with no associated transaction. What we want to focus on are the rows that are bringing in some revenue. And that's the transactions. All right. Any questions here? So we've done a couple of steps. We've looked at the distribution of revenue by category. We've realized just doing it in sort of raw numbers isn't going to work. The visualization just doesn't allow us to see what's going on. So we took a log, and that helped, but we also found that there were a bunch of zeros. To figure out where the zeros were coming from, we broke out the transactions by event. And we found that transactions were the type of event that we would be looking for. All right, so nice. So this is the distribution, and then we summarized using a box plot. So what we're gonna do, we've talked a bit about filters. So what we're going to do is filter just for transactions. So let me talk you through a little bit more about filters. What we're going to do with this line of code is to just select all of the rows that are equal to transaction. So if you want to copy this code, that's there for you. But I want to talk you through how to think about performing a filter. So what I want is to create a new data set of just the transactions. I want to take out everything that's not a transaction and only include in the data set the transactions. So let's just call this new data set transactions. Gemini is getting very good these days and has preempted what I'm about to write. But fundamentally what we want is we want to tell Python to only select the rows that are equal to, or the column event is equal to transaction. So I'm going to say data, and then I'm going to give it these brackets. And then something is going to go inside these brackets, which will return true for the rows we want and return false for the rows we don't want. So that's just going to look like data, and then we want event. And then we just want to check, this is our logical check, whether the row is equal to transaction. So I'm just going to say transaction. And then we'll just run the header. If I run this, I'm going to get only the rows where the event is equal to transaction, taking out everything else. And to check that I've done this correctly, I'm just going to get a value count for the new event. So I'm going to look only at the transactions, look at the column event, and then construct a value count for that. And you can see here I've selected only transactions. So in the value count table, I'm only seeing transactions, nothing else. Okay, any questions here? I think this is the most code we've done in one class period. Does it feel like that? Y'all doing okay? No response. Okay, sounds good. So this is nice. We have our transactions data. What are we doing next? Well, I have some slides here, but we're not actually doing a whole lot extra in the slides. All we need to do is summarize this new data set just like we did before, but now we've actually excluded all the zeros. So we're not going to have that zero problem if we've done all of our work correctly. So let's take a minute here. Let's summarize our transactions data set. Turn to your neighbor, tell them which one of these behavioral interventions is leading to the highest amount of revenue per transaction. And in the meantime, tell them they're amazing at code for being able to construct figures like this.
We talked about this. I feel like the first one. I think so.
Yeah, the strip club is a little bit distracting. So,
Okay. How many of you got a figure like this? Does this look about right? I mean, it might look different. I put a lot of work into styling these to make them look nice. Yeah.
Rates with the submission is asking for the relationship between golf and GDP.
Oh, yeah.
That's would you say best?
Maybe you should give me 5 more lecture points. The question is not matched to what we're doing today. So you can just upload one of the figures. I would say this is the best one for it. Yeah. So I'm, up to 25 lecture points today? Am I winning? I think I have the most.
Did you get?
Do you all see a figure? Are you creating a figure that looks a lot like this?
yeah.
What does this tell us about the behavioral response to incentives? Yeah, Evan.
It doesn't look like there's a super significant amount of variation. Like,
Okay.
They all look like they're generally around like similar places.
So like the median
Yeah, the
is
median
not that different.
Not that insane.
Okay. Yeah, what else? So Evan's saying maybe the median isn't so different between them. Any other ideas? Any other observations? Yeah.
The minimum is a lot higher for the over 5 to 10.
So BOGOs are not getting a lot of the small values. Yeah, so the minimums here are much larger than they are in these others. Any ideas about what's going on there? Yeah, Mairead.
Well, people probably are going to spend much below the required target for users, which is $5.
Yes. Right, so like, yeah, we're sort of cut off at the bottom for the BOGOs. Yeah. Yeah, but this looks a little funny. Certainly the medians are like in magnitude pretty close to each other. And remember, we're doing this in logs, so the like any sort of small difference is sort of compressed in a way that we might not be able to see meaningful variation between groups. One thing, we started with the question of comparing the BOGOs. So there are a couple of things that are, I think, interesting to note here. And our main question is which offer type has the higher spending? We're going to come back to this in a second. There's a little bit here on grouped statistics. If you're interested in the grouping directly, we can create these summary tables of the groups directly using this code. So we can just go through and actually do a bunch of grouping. And in past semesters, we've spent some time doing this, but it's not the most important or like core skill. So for the sake of time, I actually don't want to get into this too deeply. But if you're interested in constructing summary statistics like this, we did this a little bit last class, and there's a little bit more code here to construct summary statistics by groups, something that looks like this. This would give us actual point values. So if we're comparing between groups, sometimes the actual point value can be useful. The medians themselves, comparing visually, sometimes it's a little bit hard to distinguish. So sometimes this can be actually the more useful summarization tool. but really only after we've gone through the visualizations. So using the group statistics, we can see this one has the highest mean. Well, I guess second highest. Oh, 5 more lecture points. Isn't that nice? So these are basically tied, but this is maybe slightly higher. And we can see BOGO 10 has a higher mean than BOGO 5, which is our main question. So comparing between the two BOGOs. How many of you at the beginning of class, remember I asked you which one you thought was the largest behavior response? How many of you answered BOGO 10? Hands up. How many of you answered BOGO 5? Interesting. So let's think about this. Remember, at the beginning of the semester, the economists, sit down and think about minimum wage and such, right? We sit down in our fancy leather chairs and talk to each other over coffee. We come up with a theory that makes a prediction about the world. At the beginning of class, I asked you to make a prediction about the world. You came up with some, it wasn't math, right, to construct an economic model, but you had an idea for how behavior might respond to incentives. And you came up with a prediction. That is an economic theory. It's a very small one. It's not meaningful in any big way, but it is an economic theory. Not to trivialize your theories, right? But then what we did is we went out into the world, we collected some data, and we put it to the test. And we see that just comparing the averages, BOGO 10 brings in more money per transacted offer than BOGO 5, which allows us to sort of, in some ways, test our model that we came in with. These are the kinds of things we do. This is why we spent, why we're spending this semester talking about these things. It allows us to arbitrate between models. There's a whole lot more to do with this, but this is kind of the idea. It allows us to to test our models using actual data. Any questions here? Yeah.
I'm looking at the exercise question, and it's talking about coffee and GDP.
Yeah, that's my mistake. So I think, what am I up to, 30 points today? You can just submit one of the figures we've created today. No, that's my bad, not yours. Yeah. Yeah, any other questions?
Just to continue on that, you want us to submit this most recent one that we got rid of that we needed at 0.
Yeah, so submit this figure. Just looking at the distribution of transactions by offer type. Any other questions? Do y'all like getting class credit for doing the work we do in class? Yeah, I think that's nice. Okay, so this is not the whole story. I asked you if it was. Turns out this is not the whole story. We're looking at averages, but I want to just zoom into these two offer types and make a bit of a comparison that we're going to pick up next week. This is what we did. So we did a bit of a filter. We selected only the transactions. We did a log transformation to sort of de-skew the data. We did a bit of grouping. So we did this with a box plot, but the box plot behind the scenes grouped and then plotted by group. So this was just the distribution to give us the box plots, which allowed us to summarize by group. And you'll notice one of the important things I wanted to show you today is that this process is not linear. We started without a filter, right? We just looked at all of the data and we realized that we needed to look only at transactions. So sometimes we have to sort of double back. So if you felt like the flow was a little bit funny, this is exactly how we think about data. Or I should say it's often how we engage with data. We'll sort of proceed forward and then double back. often what you'll encounter as you work with your data sets is not linear. But this is the general workflow. So we created a figure that looks like this. And you'll notice that there are meaningful differences between the means or the medians. Or I should say there are differences between the medians. And we found that BOGO 10 was slightly higher than 5 off 20, and it was definitely higher than BOGO 5. But one of the things you'll notice with this figure is that there's substantial variation within the distributions. Like, the distributions themselves overlap significantly. So to highlight this right before we go, I want to show you just a comparison between these two groups. So here I have BOGO 5 and BOGO 10. And you can see much of the overlap, much of the distributions overlap with each other. So this gray area in the background, you can see, so this is sort of this area between the bottom 25% of, so the bottom end of the box. And you can see lots and lots of the BOGO 5 is actually above the 25th percentile for the BOGO 10. And you can see the same thing, or a similar thing, with the 75th percentile of BOGO 5, right? So much of BOGO 10 actually sits below the 75th percentile of BOGO 5. These distributions overlap substantially. Much of the data in BOGO 5 is greater than much of the data in BOGO 10. So when we're comparing the averages, you can see BOGO 10 is higher. And it's higher than most of the data in BOGO 5. But there's a lot of overlap in the distributions. So does this mean that BOGO 10 is higher? Like, BOGO 10 brings in more revenue per transaction? Yeah, Mairead? Is BOGO 10 meaningfully different than BOGO 5? The distributions overlap. How do we know? Well, from this picture, we can't. We're going to spend essentially the whole second half of the semester trying to arbitrate whether these two kinds of things are different. We're going to introduce what we call a t-test. Many of you have seen a t-test before. I think if you're in this room, you've seen a t-test before and you've run one. We're going to talk about the intuition for how they proceed, what is it actually telling us? And we're going to spend a lot of time digging into the intuition and how to run them. But this is the fundamental idea. We want to test whether BOGO 10 is actually greater than BOGO 5, even though the distributions overlap. So this is about where we'll leave it. There's a little bit more to say here, but this is the main thing we'll start asking in part 3. So what did we do today? We talked about summary statistics and how they allow us to see underlying problems with our data. Then we talked through a workflow, sort of thinking through how we can meaningfully display the data visually, which involved filtering. So we talked about some filters. We did another log transformation. And then some of the summaries we used, the main one was just a box plot, which will be very helpful when we start thinking about comparisons by group in part 3 and 4. This is the building blocks. So we talked about numerical and categorical variables. All of this was in cross-section, so just transactions through time. And then our operations were filtering, transformation, and then we did a bit of group by, but we didn't spend a lot of time on that today. We talked about bar charts, box plots, and then strip plots. So this is part 2.2. The homework 2.2 is coming out later this afternoon. Homework is, as you have started to expect, hopefully about half an hour. So not a big amount of work. So that'll be due on Friday. Let's see. And then mini exam 2 is a week from today. So this is after getting through the first part of the semester, mini exams would be roughly every 2 weeks. You'll get a mini exam demo. If you felt like there were things that you needed going into the last one that you would wish for in the next one, just send me an email. Mini exam 1 is graded and sent back to you, so take a look at that. I was very happy with how mini exam 1 went, so take a look. I'll see y'all in the next one on Thursday.
Thank you.
Yeah, see you.